one opening mistake. Mike Lane and Abby Dan. They will fill us in on all the latest and greatest as to winter weather in New York State. What more can you ask for? Who's going to lead off? Okay. If anybody can't hear, let us know. And if you want to take questions, you can go to the change of questions.
Questions? Just if anyone has a question, feel free to raise your hand, drop me, whatever.
Okay.
So thank you all for coming tonight. I'll try and talk loud. If you can't hear me, just say something and I'll try and talk louder. So I'm Mike Lane, my colleague Abby from the Weather Service. We're excited to talk about winter weather. Hopefully we'll actually get some winter weather this winter. But so here's kind of a brief outline of the presentation. We're going to start off just kind of talking a little bit about the National Weather Service, the Weather Ready Nation program. And then we'll go through some spotter safety, kind of an outlook for what we might expect this upcoming winter. We'll talk a lot about winter precip types, different types of winter weather events, snow, ice, freezing rain, stuff like that. We'll have a short break, and then Abby will take over and talk about some cold weather forecasting, winter flooding, and how to send reports into the National Weather Service. So starting off, this is a picture of our office building. So we're in the ETech building, which stands for Emerging Technology and Entrepreneurship Complex. It's a huge building right on the New Albany campus. We're located with the Atmospheric Science Research Center, the Department of Atmospheric Sciences, the New York State Mesonet. There's a couple other weather entities in that building I'm forgetting, but it's really nice having all these meteorologists in one place. And as far as our office goes, we have a meteorologist in charge who is in charge of the entire office. We also have a warning coordination meteorologist, a science and operations officer, and an electronic systems analyst, and they make up the management team. We have a total of 13 meteorologists. We usually have, when we're fully staffed, 6 lead meteorologists and 7 general meteorologists. Myself and Abby are both the general meteorologists. We have 3 electronics technicians who fix our equipment, help with systems upkeep. We have an IT officer who does more of the software side of things. An observing program leader who she does a lot of work with the cooperative weather observers who send us information. A service hydrologist, she really handles anything related to flooding or water. And then an administrative support assistant, which is basically like a secretary. And we are open 24 hours a day, 7 days a week, 365 days a year. So as far as the forecast area that we cover goes, we have parts of New York, Connecticut, Massachusetts, and Vermont. We have 6 other National Weather Service offices that border us. So here in the Mohawk Valley, kind of the office that covers areas kind of west of here, is the Binghamton office. And then a little bit further north and west, the Buffalo office, they have a border with us up in the Adirondacks. And we have Burlington, Gray, Boston, and New York City to the kind of going around the loop there. As far as the topography of the area that we cover, we have a lot of mountains and valleys. So you'll see the Adirondacks, Catskills, the Berkshires and Southern Greens in western New England. And then the Hudson Valley runs north to south, and the Mohawk Valley runs east to west. So I believe roughly half of our forecast area is above 1,500 feet in elevation. And when you have these big differences in elevation over such a short distance, it can have a really big impact on the weather that everyone gets to experience. So moving on to the Weather Ready Nation, there's a lot of text on this slide. I don't want to spend time reading all this. But essentially the Weather Ready Nation program is a program that the Weather Service participates in. And the goal is to work with communities to improve their ability to protect against natural disasters and then to recover from those natural disasters. And so by coming here today and talking to all you guys, we're helping to build a more weather-ready nation to help make you guys aware of different kinds of winter weather, the hazards that winter weather poses. And then also by sending your reports to us, you're also helping us better prepare for winter weather and help to warn other people who are in the path of this safety is top priority. You know, we don't want people going out putting themselves in harm's way just to send us weather reports. So please only send us weather reports if it's safe to do so. And then here we just have a couple of infographics on driving in winter weather. So, you know, we have the typical one kind of on the right-hand side with slippery roads and snowy conditions. You know, I think most people know that that's a hazard. But even on clear days when it's windy, we get a lot of wind here, especially in this part of the Mohawk Valley. It can get quite windy in the winter. And even something just like strong winds can pose a hazard when you're driving. So, you know, always encouraging people to keep safety in the front of your mind. So we'll move on now and talk about the outlook for the upcoming winter season. So currently, the experts at the Climate Prediction Center are expecting La Nina weather pattern to emerge, persist really through early spring of next year. So this graphic here on the screen kind of shows typically what we see during a La Nina pattern. Now there's a lot of other influences besides just the La Nina, but the La Nina is usually kind of one of the main drivers of our winter weather. So typically with La Nina patterns, we have an active storm track near the East Coast. A lot of it colder, sometimes we kind of north and west of upstate New York. We can get some pretty wet winters, but it's not always super cold in a La Nina pattern. And if we flip ahead to the next slide for what the Climate Prediction Center is expecting for their winter outlook, we see it kind of looks pretty similar in regards to temperatures and precipitation to this conceptual model here. So for New York, they're kind of leaning slightly towards above normal temperatures this winter on average, and near normal precipitation. But again, you can see, you know, not that far west of us, they're leaning towards above normal precipitation. So if that storm track were to shift a little bit further south and east, then, you know, maybe we could end up on that weather side as well. You know, the people at the Climate Prediction Center are the world experts in long-range weather prediction, but no one is perfect. So while this is, you know, kind of their best guess of what happened, there definitely could be some wiggle room. And even if we have an above average winter in terms of temperatures, it doesn't mean we can't get cold days or snowy days in there as well. Speaking of our kind of a typical winter, what we see, looking at snowfall amounts, you know, snowfall amounts range from over 150 inches up in parts of the Adirondacks to 20 to 30 inches in the Mid-Hudson Valley south of Albany. This part of our forecast area out in the Mohawk Valley tends to do pretty well during the winter, averaging somewhere ballpark like 50 to 70 inches of snow, with a little bit more the further west you go, closer to the Great Lakes. Yeah.
There's a road going through, is that the thruway or is that 20 or?
This one right here?
Yeah.
That is I-90.
I-90, that's the thruway.
Yeah. And so looking at last winter, this was the observed snowfall for the winter. We can see on the left-hand side, this is the actual snowfall amounts, and on the right-hand side, this is how the snowfall amounts compare to a normal winter. So out here in the Mohawk Valley, it looks like we saw generally 50 to 60 inches of snow. And looking at the map on the right, pretty much everywhere across the board in the area that we cover had a below average winter in terms of snowfall last year. So as you get a little bit further east in the Mohawk Valley, they were a little bit closer to average. The western parts of the Mohawk Valley were, you know, it looks like several inches below normal for their seasonal snowfall. So personally, I'm hoping that we do this talk next year, looking back and say, oh, we had a really good winter in 2024-25. And then so here's zooming out to the state of New York, a map showing the average snowfall in a typical winter. The color scale is a little bit difficult to see here, just because down in New York City they average, you know, not a whole lot of snow, generally around 20 inches or so, compared to parts of the Tug Hill Plateau down into the Great Lakes average like over 220 inches of snow in a typical year. So this is just kind of a zoomed out map of New York State, the average snowfall in a typical winter. All right, so now we're kind of getting to the meat of the presentation, talking about different winter weather precipitation types and winter storm events. So there's kind of 4 different types of winter precipitation that we talk about, snow, sleet, freezing rain, and rain. And we'll kind of go through a little bit more information on how each of these precip types forms. But generally, if there's no if there's no warm air aloft, you're going to get snow. If you have some warmer air aloft, you'll get sleet or freezing rain. And if the entire column is above freezing, then that's when we typically will have rain.
What about we get gravel?
So gravel is, it would fall in the snow category. Usually the entire atmosphere is below freezing. So if we'll kind of take the perspective as if it were a snowflake like falling out of this cloud here. So snow is kind of the easiest one. The entire atmosphere is below freezing. That snowflake, as it falls out of the cloud, it continues through below freezing air until it gets to the surface. There can be different kinds of snow. We get heavy wet snow when temperatures are closer to freezing. We can get as much as 1 inch of liquid only resulting in 5 inches of snow when it's kind of that wet and heavy consistency. It's more typical that around 1 inch of liquid will result in 10 to 12 inches of snow, so that's kind of a typical, your average snow. Then the really kind of dry or fluffy snow, you can get as much as 30 inches of snow out of just 1 inch of liquid. Light fluffy snow is more common with cooler temperatures, and a lot of times lake effect snow is with that lighter, fluffier consistency as well. So the next thing we'll talk about is sleet. So again, taking that perspective of a snowflake falling down out of the cloud. Initially, the snowflake forms in air that's below freezing, but if you get a layer of warm air that's above freezing, somewhere a couple miles up above our heads, that snowflake will actually melt as it falls through the warm air, and then if that warm air is shallow enough, the snowflake will refreeze into a little ice pellet before it gets to the surface. And that's what happens is sleet. A lot of times you kind of hear as it painting against your window. That's sleet. It's like almost like little tiny marbles of ice that can look like. And so some impacts of snow and sleet. I think transportation issues is probably the biggest one. Slippery walking, driving conditions, airport closures and delays, railroad delays and closures. Snowfall rate is something that a lot of the DOTs and public works are really concerned about, because the faster it comes down, the harder it is to clean up, the more it can reduce visibility. So sometimes we'll talk about 1 inch of snow per hour or 2 inches of snow per hour. When we get snowfall rates of 2 inches per hour, that typically reduces visibility to a quarter mile or even lower if it's windy out and blowing snow around. So 1 to 2 inch an hour snowfall rates is pretty impressive for upstate New York. Other impacts of snow and sleet, especially early in the fall or late in the spring. There's leaves on the trees. The weight of the snow combined with the weight of the leaves on the trees can bring down branches and lead to power outages. Blowing and drifting of snow a lot of times is an issue, even like after the snow has already fallen, when it gets windy out as the storm moves away. You can get roads becoming snow covered again just from that blowing and drifting of snow. And occasionally we do have winters where we get numerous heavy snowstorms over a period of a month or two. And if that snow doesn't really melt in between the storms, the weight of the snow can actually lead to some roofs to collapse. Moving on to freezing rain. So again, we'll pretend that we're that snowflake kind of falling out of the cloud. But with freezing rain, there's a much deeper layer of warm air aloft up in the atmosphere. And so in this case, as the snowflake falls into that layer of above freezing air, it melts. But because that layer is much deeper, and then there's a very small cold layer near the surface, that snowflake doesn't have time to refreeze back into an ice pellet. So it's essentially, once it melts, it's water all the way until it hits the surface. But because the surface is below freezing in this setup, the water will freeze into that solid sheet of ice on contact. That's freezing rain. Freezing rain is very impactful. Even a very small amount of freezing rain can cause extremely slippery travel conditions, walking conditions. Freezing rain is much more difficult to drive in than snow or sleet. If we get about a quarter inch of freezing rain accumulation on the trees, we'll start to get branches coming down. A half inch of freezing rain accumulation will cause more significant power outages that can last a very rare occasion we do get an inch or more of ice, that's when we get really widespread power outages that can last several days to even a couple weeks. Anytime you get wind in combination with freezing rain, the wind kind of blowing the trees around, plus the added weight from the ice on the trees, will make the power outages even worse. Alright, so kind of covered the different types of winter precipitation now, so we're going to shift gears a little bit and talk about some different types of winter storms. I just want to check in, see if anyone has any questions, and if not, we'll continue on with the presentation. Alright, so the first kind of event we're going to talk about is overrunning. Essentially what overrunning is when you get warmer air moving up over a layer of cold air. So this happens quite frequently this part of the country in the wintertime. A lot of times we'll get a warm front kind of approaching from the south or sometimes from the west. This warm air associated with that warm front, it'll rise up and over the colder air, which is more dense. That warm air rises up and over the cold air. Moisture condenses out in precipitational form. Sometimes the precipitation will fall as snow, sometimes it will fall as sleet or even rain, especially heavy rains in the winter. So an example of a storm that had a lot of overrunning was the December 1st through 3rd, 2019 snowstorm. So we had kind of two phases of the storm. The first, there was a lot of heavy snow for several hours. The afternoon of December 1st into the 2nd. And then there was kind of a break where we just had light, occasionally moderate snow for about 20 hours or so. And then beginning on December 3rd, the snowfall rates picked up again, 1 to 2 inches per hour. We got several more inches of snow before the storm ended. The morning of, I think I should say, December 4th there, all the way up to late. So this storm was kind of a coastal storm that tracked off the East Coast. We had widespread precipitation, kind of out ahead of the storm's warm front, and so that warm front coming at us from the south, that's why we had overrunning precipitation. We got the snow from the storm. Here's a radar route I'll let you show a couple times. This kind of initial batch of precipitation, that's associated with the overrunning. And then you'll see there's kind of a period here where it's just more scattered precipitation, it's a little bit lighter. And then once the storm begins to intensify off the East Coast, towards the end of the loop, we get to see some more kind of advanced precipitation moving in. We'll talk a little bit more about those later with nor'easters. Here's where we kind of see that those bands of heavier snow starting to form again before the storm moves off to the east. So this storm, I know some of you might remember this storm. This part of the Mohawk Valley had a general kind of like 8 to 12 inches of snow from this storm. But further east in the Capital District in Albany, we had, I think, close to 2 feet of snow. So this was definitely a very memorable snowstorm. A lot of places end up with over 20 inches in parts of the Capital District in western New England. So the next kind of storm that we'll talk about is the Alberta Clipper. So these storms typically form in Alberta and western Canada, and then they'll really quickly track near the Great Lakes and into upstate New York. Typically they bring light snow with them. Usually the snow falls kind of along and north of where the low pressure system tracks. And then a lot of times behind these storms we get really, really cold Arctic air moving into upstate New York. So here's an example of an Alberta Clipper. This was in February of 2022. So the storm developed in Alberta on February 17th, and then by February 19th it already had made it to upstate New York. It would bring a little bit of snow and some very cold temperatures to the state. And here's a radar route of some of the snow associated with that storm. So you'll see there's kind of this initial burst of snow. It's kind of a light to moderate snowfall kind of as the storm tracks through. And then you see kind of coming into the back of the frame now, when that really, really cold Arctic air moved over the Great Lakes, we actually got what are called snow squalls. We'll talk about the snow squalls later on in the presentation. But this kind of line moving through the Mohawk Valley right now with the snow squalls typically feature a very narrow area of really, really heavy, intense snowfall. And then there was even some lake effect that developed on the very back of This really just refers to any storm kind of tracking off the East Coast, usually south of Long Island, east of Cape Cod. These storms get a lot of attention, especially in the news, because they tend to impact the I-95 corridor, which is where a lot of people live. So they can drop a lot of snow from DC to Philly to New York to Boston. Some of our biggest storms that we get are nor'easters in this part of the country as well. And here's an example of a nor'easter from March of 2023. So I remember the storm very well. The storm kind of started down here off the coast of the Carolinas, then it tracked further north. This one actually tracked a little bit further inland than a lot of nor'easters do. The storm kind of located right near, right over Cape Cod by the end of the loop there. That's 2 p.m. on March 14th. And so here's a radar loop from the storm. So you'll see initially there's kind of a lot of light precipitation ongoing at the very beginning. You kind of see a little bit of a break, especially in parts of southern New York, before kind of more moderate to heavy precipitation begins to move up from the south. This was a long duration storm, so I think it snowed for quite a while in parts of eastern New York and western New England. Here you see some of the heavier precipitation moving in. You see really heavy precipitation kind of extending along the I-95 corridor from New York City through like Hartford, Connecticut, upwards to Boston area. And there's also a lot of heavy snow falling over parts of upstate New York. I remember with this storm, there was a band of really heavy snow with 2 to 3 inches per hour that set up over parts of the Adirondacks. We'll show the snowfall not here in a minute, but this was a storm that, if that band had set up just 20 miles further to the east, Albany would have gotten a lot of snow, and there's a lot of very unhappy meteorologists in Albany that day, hoping for some more snow. So I'll just let this loop play out here for a minute. Kind of as the storm is pulling away at this point, the precipitation starts to taper off. So here's the snowfall map from that storm. Because the storm occurred kind of in the middle of March, a lot of the valley areas were kind of warm, so the heavy snow fell over the high terrain areas. Parts of the Adirondacks had 20 to 30 inches of snow, same with the Catskills. We had a couple of reports of over 40 inches of snow in southern Vermont with the storm. And it may be hard to see on the map, but one thing that was really interesting is in the Mid-Hudson Valley, and I'll try and highlight that with the maps here. You went from having less than an inch of snow down the valley to just 7 miles away up in the Catskills, 2 to 3 feet of snow. So really drastic changes in snowfall over really short distances. Here's a couple pictures that were sent to us. The one on the left is from one of my followers on Twitter. Kind of the 2 middle pictures I took up at Thatcher Park in Albany, which is about 1,000 to 1,200 feet in elevation, just kind of southwest of the city of Albany. And we had another picture on the right-hand side that someone sent us on Twitter, and I think that ruler was showing almost 43 inches of snow that they measured. So really impressive snowstorm in parts of western New England. Another example of the nor'easter was December 16th and 17th, 2020. I know some of you may remember this storm. This storm was unique. It wasn't a particularly strong low pressure system, but it dropped a lot of snow in a really short period of time. This is one that parts of the Capital District, Saratoga, Lake George area, even parts of the Catskills, eastern Mohawk Valley. People went to bed with very little snow on the ground and woke up to like 3 feet of snow the next morning. So this storm was kind of unique that we had persistent snowfall rates of like 4 to 6 inches per hour for several hours, and then it was just kind of in and out very quickly. So the next kind of storm that we'll talk about is a bomb cyclone. So this term has kind of become popular on the news and the media in the last several years. What a bomb cyclone refers to is just how quickly the storm strengthens. So anytime the central pressure drops more than 24 millibars in 24 hours, storm is considered a bomb cyclone. Usually, if there's a bomb cyclone nearby, it'll tend to be a bigger storm for upstate New York, but sometimes you can get a bomb cyclone that passes out into the Atlantic Ocean, well to the south and east of us without really any impact. A lot of bomb cyclones tend to be blizzards, and a lot of blizzards are bomb cyclones, but you don't have to have one in order to have the other. By the definition of a blizzard, the only things that are required is blowing snow, 35-mile-an-hour winds, and visibilities of less than a quarter mile for at least 3 hours. So you don't even need snow to be falling in order to have a blizzard. You could actually have what's called a ground blizzard when snow that's already fallen is blowing around on the ground. Those kind of ground blizzards where there's no snow actually falling are a little bit more common out in the Midwest. Usually here, if we have blizzard conditions, there is snow falling from the sky, but it's not a requirement for a storm to be called a blizzard. Something that I think a lot of people in this part of the Mohawk Valley are familiar with is the lake effect snow. So this is very unique that there's not a lot of places in the world that get the kind of lake effect snow that upstate New York does. And kind of the way lake effect snow forms is you have very cold air moving over the Great Lakes, which tend to be much warmer. And the warmer lakes, they kind of warm the air and put a lot of moisture into the air. And then as that air gets warmer, it begins to rise, and all that moisture condenses out in the form of snow as that warm air kind of moves off of the lakes and over land. So lake effect snow can have really high snowfall rates. It's not unusual to have 3, 4, 5 inch an hour snowfall rates in lake effect snow bands. These can be pretty small scale in areas, so you could be driving, and the band itself may only be 10 or 20 miles wide, and it can be really difficult to drive while you're in that band, but on either side, it can be bright and sunny. So these cause a lot of problems for that reason. Because it snows so hard, it can cause a lot of problems on interstates. And some of those maps we showed at the beginning of the presentation with the really high snowfall amounts on average in parts of western New York and the Adirondacks, that is really due to the lake effect snow those areas typically receive each year. And so here's a few examples of kind of different lake effect snow bands that develop in different wind directions. So here in the Mohawk Valley, we kind of want a northwest to west-northwest wind. So when the winds come from the west-northwest, it'll kind of focus the band towards the Mohawk Valley. If it's a little bit more northwesterly, it'll focus it a little bit more towards the northern Catskills. Sometimes these bands can be long enough they even extend into the Capital District or western New England. When the winds are directly from the west, that's when the bands tend to be a little bit north of the Mohawk Valley across the Adirondacks, the Tug Hill Plateau. And when the winds are from the southwest, that's when like the city of Buffalo tends to get their biggest snowstorms. That's kind of what happened. I think it was maybe 2 winters ago. They had some ungodly amount of snow. It was like 80 inches of snow, and over the course of a couple days. So we mentioned snow squalls a little bit earlier on in the presentation. Snow squalls also typically form a lot of times with Alberta clippers. When we have like a cold front bringing in a really cold air mass, that air mass moves over the Great Lakes. The Great Lakes, kind of similar to lake effect snow, can add moisture to the air and help create these snow squalls. But usually you need some sort of a cold front as well in order to get these. Snow squalls are really intense bursts of snow and wind. Again, the band is usually, or snow squalls is usually very narrow, so it can be sunny on either side of that band, but if you're driving through it, it's whiteout conditions, it's almost impossible to see. And a lot of times, behind the snow squall, you'll get rapidly dropping temperatures, which can cause any wet road surfaces to freeze, becoming really hazardous to people who are driving. So the National Weather Service does issue snow squall warnings because they're such a hazard to people who are on the roads. These are kind of like a severe thunderstorm warning, in that they're targeted towards a small area where the greatest threat is. And they're usually only in effect for about 30 to 60 minutes. We have the ability to trigger the wireless emergency alert function on your phone. So if you are in an area or the cell tower that your phone is getting signal from is in the area of a snow squall warning, we determine that it's a dangerous enough snow squall that will actually make your phone kind of beep at you and make this very annoying alarm noise. If you do see that snow squall warnings are issued, you can avoid traveling. That's the best course of action. But if you can't avoid traveling, then it's best to slow down or kind of find a safe area to get off of the roads, even just temporarily, as the snow squalls pass. Here's an example. See if this video will play of snow squalls kind of coming into downtown Albany. And so this was taken up in a high-rise building. And you can see how, on the right part of the image, it's a normal day, it's perfectly clear. But when the snow squall, it's just a wall of snow coming in. And, if you're in the snow squall, you can't really see much of anything. You can see how suddenly it comes on. The sudden nature of the snow squalls combined with the visibility, again, is a big hazard to anyone who's driving. I think the last type of snowstorm we'll talk about is upslope snow. Upslope snow happens when you get air that's kind of forced up against the mountains, and as it hits the mountains, it'll rise. The air will cool, the moisture will condense out of the air, and snow will fall over the mountains. So there's a little bit of this happens with the lake effect snow up in the Tug Hill because it's a higher terrain area. So that kind of increases the snowfall totals there. But upslope snow can happen anywhere that there's mountains or terrain. One area we typically see it in our forecast area is actually in western New England. As we get with kind of like a west or northwest wind, we'll get air kind of coming like right down the Mohawk Valley through the Capital District. And then as it hits the Berkshires in western Massachusetts or the southern Greens in Vermont, those mountains kind of force the air to rise, the moisture condenses out, and snow falls over the mountains. So here's an example of an event from around Thanksgiving a few years ago, when most of our area actually only saw 1 to 2 inches of snow. But over the mountains, with this upslope snow, we had anywhere from like 12 to 16 inches of snow in some areas. So again, kind of a fairly localized, usually fairly localized event. Happens because of the unique terrain in upstate New York and western New England. And we'll now move on, we'll talk about ice storms. So the way an ice storm forms is it's kind of similar to overrunning, and we'll get kind of this cold air will get kind of wedged in at the surface. A lot of times if we have high pressure to our north and east, it'll help to reinforce that cold air. And then you get kind of warmer air rising over that cold air. And so the precipitation will fall through that layer of warmer air. It'll melt, and then the layer of cold air at the surface is usually very shallow. And that melting snow won't have time to refreeze and sleep, so it becomes freezing rain when it hits the surface. Ice storms can, when we have the big ice storms, result in a lot of damage. And so a couple things to do ahead of an ice storm. It's always good to kind of trim trees or branches around your house. Don't leave your windshield wipers raised because the weight of the ice can actually damage the wipers. Have plenty of food and medicine. If there's a major ice storm, the possibility of prolonged power outages. Don't park your car under a tree, and keep your devices charged if there is a risk. Your phones, the computers charged if there's a risk of losing power. So here's a couple examples from some ice storms. This one was actually in March of last year. Most of the Mohawk Valley actually got quite a bit of snow, 8 to 12 inches. But there was kind of a pretty small area right around the Albany area in the Capital District that had as much as a ½ inch of freezing rain. Here's some pictures that were taken, some of these by Weather Service employees, one of them by a guy who's on public radio. You can see all the ice on the trees in and around Albany. You can see some of the damage from the way Another example of what ended up being a pretty localized ice storm was back in February of 22. So if you watch this animation on the right, it's a model forecast, but as the cold air is kind of coming down from the north, you can actually kind of see as the precipitation in the Hudson Valley kind of changes from rain over to ice, then a brief shot of light snow at the end there. So again, the Mohawk Valley, and from this storm, got quite a bit of snow, kind of a widespread 6 to 10, 6 to 12 inches of snow. Not a whole lot of ice in this part of the area. But further south, especially Ulster County, was really hard hit with some places had close to an inch of freezing rain. Resulted in a lot of power outages where some people without power for close to a week, if not even longer. Here's some pictures from that event. You can see, just a ton of ice on the trees, and a lot of damage. You can see the bottom right picture there. In the town of Kingston, there was a lot of damage, down trees on power lines from all that ice. And here's one more example. This was several years ago, back in 2008, was the last, I believe the last real big widespread ice storm that happened in upstate New York. These are pictures that a couple of our meteorologists took on their trip into the office after the ice storm. Again, you can see a lot of ice on the trees and some down tree limbs and branches, especially in the picture on the left. All right, so the last thing we'll talk about before we head to the bridge is how to measure snow and ice. So we have a lot of these nice little infographics. We have a couple videos with some little cartoon characters we'll show here. In terms of measuring snow, you always want to set up before the snowstorm happens. We recommend that you have a snowboard, which is, it can really just be like a piece of plywood painted white. If you don't have a snowboard, it's not the end of the world. We'll still accept your snowfall measurement. But if you do have a snowboard, it's good to put some sort of like a flag or a marker out, because when that's buried in a foot of snow, you're not going to be able to find it. It's good to try to measure away from buildings or trees or things like that, because those can kind of impact how the snow falls. And then we'll go through how to measure the snow in some of these videos here in just a minute. So let me show you a click on each one of these, and these will explain snowfall measuring. See if I can get sound here. perfectly fine to just leave it in the rain gauge and let it melt on its own. In that case, you wouldn't be adding or subtracting any water. What's in there is, the liquid equivalent. But what they were doing there, just to speed up the process, they were adding some hot water to help melt the snow. So for example, if you add in a half inch of hot water to melt the snow, then you just have to subtract a half inch from the liquid equivalent at the end. So that's kind of what the very last part of that video there was getting at. All right. So as far as measuring ice accretion or freezing rain accumulation, there's a couple ways to measure ice.